So sign off with who am I? I'm Lewis Prince. I'm a machine learning developer for Purple Frog Systems based in the UK. We're a data consultancy. I'm a certified Microsoft data scientist and AI engineer associate. And I've got about 5 years experience working with data, primarily through R, VBA, SQL and Python. And if you want to find me on Twitter and LinkedIn, and the QR code takes you to my LinkedIn page as well. So the content of today, we'll go through what machine learning is, what AutoML is, who should use AutoML, what problems can AutoML solve for you, the common machine learning workflow, and we'll use that to kind of show you what AutoML is doing in terms of how it fits into the machine learning workflow. And I'll take questions at the end if we've got time. I will be doing 3 demos today as well. So after we go through what AutoML is, I'll talk through the Azure Machine Learning Studio, the interface, what the different bits do, and then a demo after what problems can you solve. I'll show you some data, we'll upload it, well, I'll show you how to upload it, and kind of go through how you would input that to an AutoML job, and then deploy it ready to a web API, so then ingest in Excel. Once you've gone through the common workflow, I'll show you the Excel tool and how you can write VBA to quite simply connect to that web API and predict some stuff. So at the end, I want you to be able to explain what machine learning is, explain what AutoML is, and also to be able to understand how we can use the models we create. So start off with what is machine learning. So a dictionary definition is a study of computer algorithms that can improve automatically for experience and using data. To be more explicit about that, it's something that learns off passive data. You give it old data, and from that, it does computations, calculations, gets rules, and then you can predict future instances of similar data. Something that does happen, though, to ML and AI is used interchangeably. Strictly speaking, ML is a branch of AI. I said ML, you get past data, you give it to your algorithm, it does computations, it works out the rules, and then it gives you a prediction. Well, AI is more of an agent that interacts with the environment to achieve a goal. So an example here is talking to a Tesla car, autopilot. It's talking to the road, it's talking to the environment. And it's kind of making thoughts, it's navigating around and interacting to make decisions to then achieve a goal, get to a destination. The main real difference between these two is kind of AI, it concentrates on getting success over accuracy. So that Tesla car, its goal is to get to where it needs to. If it's accurate, it's gone roundabout and it's been really efficient doing so, so be it. With ML, it's looking to be accurate over successful. So with the data you've given it, it'll try and be as accurate as possible in terms of predicting the data you've given. But it may not be successful in predicting of future data. It's prioritizing being accurate of being successful. So then what is AutoML? So it is what it says on the tin. It's automated machine learning. But what does that mean? It's automated machine learning in a small section. In particular, it's a section where your hyperparameters, your algorithms, and your pre-processing, which is a very time-iterative process. Usually, it's you sitting down, running through code after code after code after code, kind of guessing which is going to work. Sometimes you know, off an educated kind of your background, what will work and what the best guesses are. What AutoML does, it goes through many, many iterations of this for you and kind of takes the time out of it for you. It's a massive time-saving tool. And I said, it's automating the time-consuming iterative task of model development. So the really stuff you don't really need to know much about machine learning to do. It's a case of giving data to algorithms and pre-processing and just trying different combinations and keep going until you've been successful. I said there. So the first demo is going to run through the Azure ML Studio. So if I get this up. So this is what it looks like. So what we have here, first of all, you've got notebooks here. So this is more traditionally what a machine learning or data scientist would use. So in here, you can go, as stuff there, connect to your compute resources, write Python, do stuff manually. And then you have your AutoML. So all the stuff I've done in there is already there, but that's where you go to start your AutoML jobs. And you also got designer in this string. So this is kind of the traditional, the first iteration of the Azure Machine Learning Studio was kind of like pipelines. I mean, we show a little iteration now of this. And as you can see, it's kind of data flow kind of stuff, kind of going through, and you can run that, and it's very kind of click and drag, drop. And that was the first iteration. I don't think it's really used nowadays, but it's still inside the Machine Learning Studio. And then on the next ribbon down, we've got data. This way you upload your data sets, you house them, and I'll go through the D&D data set I've uploaded later on to show you kind of what the intrinsics of uploading data is on there, and how you can look through your data and do some searching beforehand, or make it done for you. Jobs. This is what you've done, the runs you've made. They're called jobs, and you'll see they get really weird names as well to anonymize them. So when you run a job, it'll give it some sort of name to see differentially between your jobs you've run. Components. So this sits back to more traditional machine learning. You can write your code, you can save it here for automation later on. So code you've already written, keep it there, but it's not really applicable to today. Pipelines, much like ETL pipelines, you can use these to kind of go through machine learning and push it through. To automate and keep a repetitive process. Environments, again, this is kind of, it's not really important to us today, but it's just preset environments where you can put your code in certain places where you know you need more computation, you need certain package versions. And the models, this is where your models are saved. You kind of click in, go in, do stuff with them. Endpoints, this is where you've exposed your models. So all the information about the stuff you've exposed, like web APIs, if you've done something for Kubernetes cluster, it's there. And then anyone really want to look at down here is computes, and this is the workhorse of your work. And you see the compute's running at the moment, and it does the work for you. And I'll show you how to kind of spin it up later on and go through the intrinsics of that. But it allows you to open it up as well in like VS Code, Jupyter Notebooks, etc. If you're familiar with Python or coding languages. So if we go back to the presentation. Ooh. Okay, so who should use AutoML? So everyone, anyone should and could use AutoML, especially in Azure. For newbies, the great point is a great access point. It requires no or relatively low coding or ML knowledge, so you can go straight in, click and drop, put your data in, and you've got a working model. You also, it's a learning tool, so I'll show you later on, when you have done your Azure ML jobs, you can see code under the hood. You can see how the tool has done it, and it'll show you the code, the hyperparameters, how it's set up, the pre-processing, and you can take that and, like a machine learning developer or a data scientist like myself, a lot of the time when they do AutoML, they'll take that away and use the code and improve upon that after the fact. And it allows access to ML solutions for all. As I said, it's a great learning tool, and it's a great access point. It just allows to democratize ML for everyone to get into. For experienced users, as I said earlier, it's a time saver. It's kind of cutting out the most time-expensive part of your day-to-day work. It introduces new algorithms as well. There's a few algorithms I've never heard of before, or new up-and-coming stuff that Microsoft puts in. And it's interesting to kind of see them popping up, see how they're performing against your more classical models you're more used to. And you can also run AutoML through VS Code extensions. So through your VS Code kind of coding environment, you can plug into AutoML and do the runs just on a Python environment. So you can save your scripts and do all the work automatically in the same like kind of clean version that's repeatable. So what problems can it solve for you? Currently, your classification problems. So this can be like yes, no to a loan, for example. When you go to the bank, it can also be multi-class as well as kind of selecting what color something it should be based on a set of parameters. So this is most you go to classification is the most common kind of problem we see. Time series as well. So forecasting oil prices, AutoML could do that for you as well, given previous oil prices. Regression, predicting store sales. If you were to give AutoML a history of your a customer's stores for the last 5 years, it'll give you a model. They could feed numbers in again and see what the store should sell in the next 2, 3, 4, 5 years, how far you want to go. And additionally, in preview currently, you have natural language processing. So a use of this could be giving it a load of scripts with labels of the genres of these scripts, and then you give it a new script, and it can tell you if it's romantic, it's a horror script, it's a rom-com. And then computer vision, so feeding it an image of loads of dogs and cats, etc. It can tell you if there's a dog in an image, a cat, etc., etc. You kind of get the gist of this. And then the only problem with the last two, it requires a more expensive compute. So it needs a GPU compute. Intrinsically in machine learning, a GPU does the calculations required for machine learning a lot better than the CPU. So when you get to the more exhaustive stuff, you really need a GPU to kind of do the work. And so in Azure Machine Learning Studio, they only let you do this stuff on a GPU, stop you wasting time using a CPU compute because it will take a long, long time. Okay, get on to the big demo, AutoML in practice. So I'll get the Machine Learning Studio back up. Okay, just an angle, I'm going to set this up right. So, first of all, we'd want to get some data in. So we do this, I've already got my data in here. But if we wanted to add new data in, create, name, it can just be SQL bits. We're not actually going to create this. It's going to show you what we're going to do. And we want to keep it tabular here. It's easy to work in CSVs. If you use tabular, that lets you upload CSVs, so it knows what you're going to use. So next, you can tell it where you want it to come from. So you can plug into your Azure storage, your SQL databases, also your local files, and they also have a set of open data sets. So there's a lot of these in here. We'll kind of show from this. You can use Microsoft PubSub. So if you do want to go home and play with this, it's probably the best place to go. And you kind of go to each one has a Microsoft documentation. So you can click Learn More, and you can see kind of what these data sets are about. But I upload from local files. So it's kind of clicking this, going next. And then you kind of say where you want to get your data from. So in this case, it's going to go into blob storage, where you want your data to go. So it's going to go to my blob storage there. And then upload. So down here, then you upload files. So you navigate into on your PC in your Windows Explorer where your file is and upload it. So I'll do that now because I've already got data in there. I'll show it now. So this is a data set I picked up online of. So if we explore, it's just a load of races. So it's a randomly rolled characters for D&D based on loads of characteristics. So your charisma, wisdom, intelligence, constitution, all randomly rolls with the races. And what the plan to do here is we've made a model which will predict what race your character is based on these other characteristics you feed in. And that's what we're going to do in the Excel later on. You can also have a profile here, and it will show you how your data is broken down as well. So it does this automatically when you upload your data, so you can see intrinsically into your data once you've loaded it, which is quite a useful tool. Okay, so going on to AutoML. Once again, I'll kind of go through this, but we're not going to do it because it takes an hour, 2 hours to go run through. But I'll give you some pointers in terms of where I would suggest you kind of do certain selections. So first off, you're going to choose a data asset. So D&D characters is what we want to use. Then you want to see if you want to add to an new experiment or an existing one. What this does, if you put it to an existing experiment, if you're doing a lot of stuff, it'll collect them all in one area, so you compare each job you've done, each run you've done. So if you've done different stuff to data before you fed it in, you can compare these. So we'll select existing here, but with creating new, it's the same as just going creating new, putting a name there. Easy peasy. Your target column. So here it's race, because that's what we want to predict. And compute type, it's going to be a compute instance. And it's going to be, while Lou's running here to, that's next. Okay, so it's already picked, it's a classification problem, because we're going to classify by race, and it picks it up itself based on what you fed in and what the target column is. It's useful to click on additional configurations. So what we're looking at here is primary metric. So when it's doing the kind of iterative process of picking your models and the pre-processing, it's going to pick what the best one is by these metrics. AUC weighted is a good one. I'll go through later on what some of these mean, but it's not really worth changing this stuff. What I do though, on exit criterion, if you're messing around with this, the default training time is 6 hours. If you're just having a play around and learning, the lowest you can put this to is 0.5, so half an hour. I'd do that just to get used to this. It's worthwhile doing it, and you get a decent enough model in half an hour. It does default out, so if it doesn't improve the model, it'll cancel the job anyway and say, I've got the best one I can already. I don't need to go to 6 hours. I need to go to 3 hours. So it does save you time with that. But it's worthwhile putting it down to half an hour if you're just playing around. And next again. And on this window, you're picking validation type and your test data asset. So the difference between validation and test here, what validation is going to do, each time it runs the job on one set of model and pre-processing, it'll do it 3 or 4 or 5 times, just to make sure the result it's got out is correct. It's the metric is correctly calculated, and it'll change around the data it's using each time, just to make sure it's got a fair shake and what it's saying is correct. And test data. So with machine learning, when you run the model, you give it a training data set and a test data set. You train the model on the training data set, and it doesn't see the test data. And then you test it on the test data, and you see how good it is. So what you're doing is not giving it a certain amount of the data you've given it, so then it's looking at unknown data. So it's how effective is it in looking at unknown data, really. I would go into this and choose a test split. Now, traditionally, this is an 80-20 split. So 80% training data, 20% test data. It's a trade-off between giving it enough stuff to train off and enough test data to know it's effective enough. There's no kind of written rule, but everywhere you look, all documentation, etc., we say an 80-20 is just a commonly accepted kind of values. Okay, then finish, and that will start running. But I blue-peated this, and we can look at one I made earlier, which will be in the jobs. See it there. Okay, Brave King. So this is what you get once the job's run, and it'll tell you what the best model was. In this case, it's a stack ensemble. You don't really know what that is, but it always will be some sort of stack ensemble or a vote ensemble, and these are a collection of all the algorithms really that's ran. So it's using a hybrid model really here. It usually is the best by saying you've got the code here of the training algorithm here, so what was ran to get that data and get that result, and what transformations were done, and what that ensemble's made up of. Now you can also go across the models, and it shows you everything that's been run. And you can see using the AC weighted, that stack ensemble is the best at 95. But you can see it's done a lot of different tests. Must be 10, 20, maybe 30. That's something that would take me a day or so to kind of do. And I did this in half an hour the other day. And so it kind of shows you how much of a time saver this really is. And if you want to look at our model, you can click this, and it gives some details there. So the first one you get is an explanation. and it loads. So the primary thing you want to look at here is that chart, and this tells you how important the features were. So if I was going to run this again, you can see weight, speed, height are the heavy hitters of this that are doing most of the work in terms of the rule making for predictions, and the rest of them are doing nothing really. So if I was going to do this run again, I'd get the data, I'd delete the rest of those characteristics, those kind of columns, because you always want to keep your model as simple as possible, because it'd be effective as possible. Because usually these models, they'll randomly pick the characteristics to choose to make these rules, depending on what algorithms you're using. Not to go into much detail, but the less choice you give it, the better it'll perform. So it's worthwhile kind of looking at that graph and seeing what are the heavy hitters in terms of your features. And then you've got metrics as well. So you see, by default, it's giving you a lot of metrics. A lot of these are redundant. The big ones are the ROC curve, accuracy, precision, and recall. You can't delete these off. They'll always come up. You just have to ignore the ones that aren't really there. But in terms of accuracy, that's how correct was it in each prediction it made. The precision is it's a proportion of all the true positives. So everything it said was positive and really was positive, out of everything you said that was positive. So reiterate that. So true positives divided by all the true positives you have and the false positives. The stuff that you were wrong about, but you said positively. And then precision is the proportion of correct predictions you made out of the total population. So that's including the false negatives, so stuff you said differently, as popped up by. Then you also have something called a confusion matrix. So this goes, and the true labels on the left, I'll zoom that in actually. So it's a heat map really, with all your races. So this is what the real label was on the left, what we predict on the top. And you're looking for bright colors down the middle. So that's everything we've said. It's a tiefling, and we predicted correctly. So you want strong colors and numbers down that middle. And then you can also normalize this. So it's not just numbers, it gives you on a scale of 0 to 1. So we were 90% correct with Dragonborn, 87 with Halflings. So that's pretty cool. And then, so we're happy with the model. It's done pretty well. And we want to deploy it. We want to use it. So we click deploy. We want to use a web service because we want to attach it from Excel, call to it, and bring our data back. So you click web service. Then you give it a name. We'll put it in a container instance, because that's the cheapest. Easy to get to. It kind of simplifies the whole thing for you. And once you give it a name, you deploy it, it's there for you to use. It'll end up in endpoints here for you. And then you can come in here, you can test it, put numbers in, or you click to consume. And it gives you 3 options here. So C#, and it gives you all the code you need to get onto that and use it. Python and R as well. But we're going to use VBA today, just because, well, I'll explain the business problem I had that maybe come towards using Excel when we come to the Excel. But all we need is REST endpoint. So we keep that. That's what we're going to put in the VBA later on to know where we're sending our request to. Okay. So back to the PowerPoint again. Okay. So this is a common workflow for a machine learning kind of problem. So it starts off with a question is asked. So a business comes and says, I want to know this information, or I want to do this. You ask the question. So you go away and you scan the data. You look and you see, have I got the correct data to do what I need to do? once you scan data, you're happy that you have enough data to do what you need to do. You then go and generate features. So when I say this, you can get correlations of different fields against each other, getting stuff over time, kind of generating stuff, deleting any repeats, getting rid of missing data, kind of consolidating stuff to make it as useful as possible to the model. And this is where a lot of the work is done. So generating features is 90% of a data scientist, machine developer's workload. And it's where a lot of the value is made. So it's the same adage of you put dirt in, you get dirt out. If you put gold in, you'll get gold out. You'll get a better model if you put in really good features. Then you do pre-processing. So I spoke about normalization earlier, kind of putting values on 0 to 1. There's other stuff you can do if you have imbalanced data sets. So if you had, for our data set, say 100 dragonborn but only 2 dwarves, it's going to be better at predicting a dragonborn race, but not good at predicting dwarves. So you can do stuff where it'll oversample the dwarves or undersample other stuff. So once again, a lot of work does come from pre-processing. It's a very important thing to do. Then once you've done the pre-processing, you experiment your algorithms. So you try different things, you see what the values were, and you go again, you go again, you go again. And once you're happy with the experiment, the algorithms, you test your final model. It may not be effective enough still, so you go back, you generate your features again, and you do the process again. And that could be a 4, 5, 6, loads of times until you get happy with that final model. And then when you put your model into production, and then you continuously test the model in production, so it can become obsolete. So if the data you trained on isn't a true representation of the data that's out there now, it's not going to be good at predicting the races anymore, for our example. So you continuously test to make sure your model's doing what it needs to do, and it's still accurate. And then the box I put up here, that is the bit that AutoML does for you. So just to give you a visual representation of kind of what is being done for you. Okay, so using output in Excel. So this is a little tool I made. Let me zoom in a bit. So yeah, actually I've got all the kind of features, the parameters we're going to feed in, and then loads of random numbers put underneath there. And then I've got the tool kind of connected to that run line. If you want to look at the VBA, we can briefly go for that. I can talk you through how I've done what I've done. So really what we're doing here is each time I click that button, it's going in and it's collecting a row at a time on that table I've made. So it's kind of creating a JSON file, so a payload we send to the API of the information we want. So that's the line up here, kind of going through, getting the weight, what value weights on that row, gathering the height, what value heights on that row. And then on the web URL, that's where the REST endpoint is, so that's where our model lives, the address of it. And then down here, this is where we pull a little thing down below, I'll show you in a second. It kind of sends our payload, we've got up there, the body, and the web URL up to our web API, and it'll take our package and return us a JSON file with a prediction in. And it's a really small bit of code that kind of does that call to the web API. It kind of takes, it's via HTTP, so it'll go through, post to the web API, give it that payload, and it'll come back with your prediction. So to show you, I'll just zoom out a bit. So it should come out over here in the race column. I click run line. So these are all randomly assigned. So they will flick about a bit. Like see here. It's loads of predictions. So elf, dragonborn, half orc. It's interesting to see here as well with the dwarf. As you saw from the confusion matrix earlier, it's probably the worst one that's characterized. In terms of worst predictions, because there's not much data in there, it's probably something you'd fix going in, but it's only because that's set to 25. So in the data set I noticed that all the dwarves have a speed of 25, and everything else has a speed of 30. So it shows how some features like this can override your predictions and derail them. If we put 25 here, it should predict 35. It should predict dwarf for all of them. Yeah, see, it's one of the things you kind of notice and see intrinsically. You could have predicted from the confusion matrix this is going to happen, and it's worthwhile kind of seeing the metrics so you can understand why stuff is being predicted in a certain way. So going back to presentation, I've gone way too fast. Sorry guys, it looks like we'll finish a bit early today because I've gone through this. It must have been the nerves. Because that's the end of my presentation, sorry. Any feedback and questions? There's my feedback link there. Yeah?
With the API, does it bring back like a confidence on the prediction?
Confidence it will do underneath, yeah. So
When you're predicting the dwarf item, it comes back and says this is a 50%.
yeah, so it'll bring back confidence to that. But you can also you can infer that confidence from the data beforehand. So from the accuracy, you can get a feel of how the confidence of what it's going to be. But also, because it's multi-class, if we're using normal machine learning kind of Python stuff, you can extract more information, and you can see the confidence per race. AutoML doesn't show you that breakdown per race. It just gives you an overall kind of averaged confidence for the whole data set.
So, because the payload when it comes back,
Yeah.
like from the demo, it just seems as if it's just the name. Is that right? Or is there any kind of metadata around it in terms of confidence or what actually drove that prediction?
I can't remember. Give me a second. We'll break out the JSON itself. So we should be able to intercept it. Just look at it for a quick second. I'll put a question mark there. I've not, sorry. No, it doesn't give you a confidence, sorry. Sorry, as long as I don't think Azure ML does give confidences out. It's one of those drawbacks of doing it. You're not getting that drilling down from it. It's useful to kind of get through and do it. I mean, personally, most people would, if you're experienced, you're going to take the model, go away, do it in Python, improve it, and then you'd get confidence off the back of that. It's probably something I'm giving in. Hopefully, it would bring it in the future. Like I said, it'd be a really good feature to know how confident you are in that result. But I think it's something you have to infer from the accuracy, the recall, and precision before, from the metrics you have. Okay, thank you. Yes?
Will there be other options for deployment in
No, I think.
Can you repeat the question?
Oh, sorry. Can you repeat the? Oh, yeah. What was the question again? Sorry.
Yes, so
Sorry.
instead of pouring the endpoint, well, we know the model, we know its parameters. There's no output we had. Can we copy the logic to Excel and VA instead of pouring the endpoint?
So you're asking instead of using the endpoint to recreate the model in Excel?
Yes.
Uh,
Or maybe copy or create the model from.
I've got no experience using Python and Excel. I don't think you can. I'm not sure if you can. I'm unsure. There wouldn't be the computation there in Excel to run a machine learning model like that. And VBA is not complex enough to create a VBA. The packages aren't there. The infrastructure are in Excel. I think the only way you could do it is by deploying it and using a web API, because it's not using my computer's computational power. It's using that compute I've got up in the cloud. Thank you. Okay, yeah. Sorry again that I finished so early. The nerves, I've gone through it very quickly. But then we can all get to the party earlier. If I get the PowerPoint back up, I'll show you the feedback again. So this is my first in-person kind of talk. I've gone quick, but hopefully you've got a lot from this. Usually I would have spoken more on stuff, but I think I've skipped over bits and I've forgotten bits. But if you give me the feedback, I'd really appreciate it. And then if you could also add me on LinkedIn and send me questions, I'd love to hear from you. And there's also a QR code that takes you to all my blogs. So I have got a blog on this topic. It's a two-parter that will probably go in a lot more in-depth than I've done today. And you can go with yourself. It'll tell you how to set up your computes. If you want to go home and do it yourself, the place to go. And you can see it on the Frog blog there. So thank you for coming again. Cheers.